Hi, my name is Bailee and today we'll be learning about how to find the sine and cosine of any angle on the unit circle. To start off the lesson, I thought I would start with some definitions. So, first I'm going to show you what a unit circle looks like. As I'm drawing the unit circle, I start with drawing my two axes. The horizontal one is x and the vertical one is y. To get a closer view, x, y. Now, a basic unit circle would be this. And this is the first part of the unit circle. Now, on a unit circle, anywhere you go, the radius is 1. So this point would be 1 out, 0 up. So 1, 0. To continue, it would be 0, 1, negative 1, 0, and 0, negative 1. Now those are the basic 4 points on a unit circle. To move further on the lesson, let's define sine and cosine. Sine is the y-axis and cosine is the x-axis. To find them, you can use SOHCAHTOA, as I will show you right now. SOHCAHTOA. As we're only dealing with sine and cosine, you don't have to deal with tangent right now. Sine. Sine is the opposite over the hypotenuse. Cosine is the adjacent over the hypotenuse. Now that we've gone over sine and cosine, we can go back to the unit circle. Here you see I have drawn the unit circle again. We're going to start with drawing our angle. So we put a line here with an arrow. This is our angle that we're looking for. We can call it theta. All positive angles go in a counterclockwise. Always remember that. Positive equals counterclockwise. You can see that up there, counterclockwise. And now that we have theta, we're going to draw our 90-degree angle, which we put right here. And we're going to call the x-axis A and the y-axis B. Now remember, in SOHCAHTOA, sine was opposite over hypotenuse. As you can see, we don't have the hypotenuse labeled. And if you remember talking about unit circles earlier, that the hypotenuse would equal 1 because any radius in a unit circle is 1. So we can call this 1. Now that we have our hypotenuse, we can remember that sine of theta equals B, which is also the opposite, over the hypotenuse, which is 1. And the cosine of theta equals A, which is also the adjacent, to the hypotenuse, which is 1. So that's the basis of how to find sine and cosine. Now let's show you with a real example. So to start with our first example, we use find the sine and cosine of a 45-degree angle. So we start off by drawing our angle. As you draw your two axes, label X, Y, and this is 0 degrees, this is 90. So 45 would lay right in between the two, making this 45 degrees. Let me fix that degree sign. Get a closer look at this. Now we can make our little triangle right there. So when you're dealing with a 45-degree triangle, the other side is also 45 degrees because you know that 90 plus 45 equals 180, which is how much a triangle equals. So, knowing that hypotenuse is always 1 on a unit circle, you know that each side would be equal, so we can call them x. When you're finding sine, is sine of 45 equals the opposite, which is x, over the hypotenuse, which means that sine of 45 is just x. So to solve algebraically, we would do x squared plus x squared equals 1 squared. So 2x squared plus 2x squared equals 1 squared, which means that 2x squared equals 1. And if we divide by 2, it would be x squared equals 1/2. So now we would square root that, getting 1 over the square root of 2, as you can see there in the steps. Knowing that you always have to rationalize, multiply each side by root 2, getting that x equals root 2 over 2. So now you know that the sine of 45 is root 2 over 2. And since both sides are x, the cosine of 45 also equals root 2 over 2. So now you've just found the sine and cosine of a 45-degree angle. Our next example is a bigger angle. As you can see, it's find the sine and cosine of a 225-degree angle. So, as we draw this angle, draw the unit circle. This is x, this is y. We're going to go 0 degrees, 90 degrees, 180, and 270. Now a 225-degree angle is going to be right about here. So that is 225 degrees. Now the special thing about finding the sine and cosine of a 225-degree angle is that what we do is find a reference angle, which is right here. Knowing that, we can say that 225 minus 180 equals 45 degrees. So we know that the reference angle equals 45 degrees. Now, after just learning about 45-degree angles, we know that this is 1, this is x, this is also x. If we remember back from the other one, the sine of a 45-degree angle is root 2 over 2, and the cosine of a 45-degree angle is also root 2 over 2. The only problem is with this one is that we're in a different spot. So our triangle is now in the third quadrant instead of the first quadrant, saying that our y value, which is sine, is going down, making the sine of a 225-degree angle negative 2 over root 2, and the cosine of a 225-degree angle, the cosine of a 225-degree angle would be negative root 2 over 2 because we are in the third quadrant. So, using your reference angles makes it 10 times easier to find angles with bigger numbers than just 0 to 90. So, find the sine and cosine of a 30-degree angle. Just draw the unit circle again. So you can call this around 30. Now, when you do this, this is 60 degrees. Now, when you're referencing a 30, 60, 90 degree triangle, remember it's like an equilateral triangle, where these are all equal. When you cut this down. So, this 60 This is 30 now. So this would be x over 2. So if you know the hypotenuse is 1, then you know that this is 1 over 2. So sine, so you know that's 1/2. You also could say sine of 30 degrees equals 1/2 over 1, which equals 1/2. Now, to find x, 1/2 squared plus x squared equals 1 squared. So 1/2 times 1/2 equals 1/4 plus x squared is 1. So x squared would equal 3/4. When you square that, you get, you get x equals √3 over 2, making the cosine of a 30-degree triangle √3 over 2. You can see that. So, if I write here, 3. Now you just found the sine and cosine